for representing integer values, whole numbers with no fractional part. The integer types include char, int, short int, long int, and long int. Some people pronounce char as char. These are all available in both signed and unsigned versions. The sizes of these types will vary by compiler and processor. The char type will typically be the minimum size to contain a character. On most modern systems, that's 8 bits. The char type may be signed or unsigned. All the other integer types are signed unless modified with the unsigned keyword. The short int type is the smallest natural size of an integer for the target processor. It may be the same as int, it may be the same as char. On most modern systems, it's 16 bits. The int type is the natural size of an integer for the target processor, and on most modern desktop systems, it's 32 bits. Long int is typically double the size of an int, and long int is either double the size of a long int or the same size as a long int. Let's take a look at these in code. Make a working copy of integertypes.cpp. Paste that into the working project and open it up in the editor here. Let's just maximize this so that you can see what it looks like. Here we are declaring variables in each of the 5 integer types. They're on lines 6 through 10. And then on lines 12 through 16, we're displaying the size of these using the size of operator. And then starting in line 18, we play around with the character a little bit to determine if it's signed or unsigned. Let's take a look at how this works. Bring this back to size and we'll compile and run it. And you see, there's our sizes. The size returned by size of is in bytes. So char is 1 byte, short int is 2 bytes, and a byte is 8 bits. So a short int is 16 bits. An int is 4 bytes, long int is 8 bytes, and long int are also 8 bytes. And we can see from this that char is signed on this system, and the way we've determined that is by initializing it with a value of 127. 127 is the largest value that you can represent in 7 bits. And so if we increment that, we know that it'll set the sign bit and it'll turn into a negative number if char is signed. And indeed, that's what happens. So char is signed. If we try this same thing with an unsigned char, and I just type in the word unsigned, you'll see, save that and run it, that when we increment it, it becomes 128 instead of minus 128. So go ahead and put that back and run it again. Sometimes you get this launching working. You can just say always run in background, or do what I do, just press the run in background button. And there we get the minus 128. So literal numbers like this are actually of type int, and in this case it's getting adjusted to the size of the smaller space for the character, and that's normal behavior for C and C++. So if I wanted to give a value to the variable I, which is an int, I could say 1, 2, 3, 4, 5, and that would put the value of 12,345 in I. If I wanted to initialize a long int, as in li, I could still use an int to initialize it, but if I wanted to initialize it with a larger value, I would put a capital L at the end of it, and that allows me to type a literal value that's a long int. 2 L's will make it long, and a capital U will make it unsigned. So if I just do that, it's an unsigned int. If I do that, it's unsigned long, and if I do that, it's unsigned long. So I'm going to save that, and we'll go ahead and display it. Save that and run it, and you can see we're getting the value there in the long int. So C and C++ provide a full selection of integer types in many sizes, both signed and unsigned. Now let's